everyone, and welcome to Radon in Water and Thoron Measurements for the Radon Sniffer. My name is Cassidy, and I'm here on behalf of Environmental Instruments Canada. I'm the daughter of Kai Collette, who is the president of Environmental Instruments and the developer of the CT007R Radon Sniffer. So radon sniffers can be used for locating radon entry points because they have a fast response time and a fast recovery time. They can be used for checking for the presence of radon-220, which is also referred to as thoron, as well as radon in water screening, and this talk will be on those last 2 points. Before we proceed, I should probably mention that I am not a mitigator, nor am I a scientist, so any questions you may have, I'm not the person to ask. My dad is here, and he can hopefully provide additional insight throughout the presentation, and he will be available at our booth throughout the rest of the day as well. So with that, we can move forward to the first topic. So why measure thoron? Thoron contributes to lung dose, meaning it can be harmful when inhaled. It can also affect the accuracy of the sniffer's algorithm because the sniffer assumes all radon is radon-222, the normal radon. When measuring thoron, it is important to measure close to the source. This could be below the slab or where radon is entering the building. This is due to the short half-life of thoron, which is approximately 1 minute. Therefore, by the time it reaches living areas, it would have pretty much completely decayed. However, the decay products are still radioactive and contribute to lung dose. Radon-220 has a half-life of about 1 minute. When radon-220 decays, it will decay into plutonium-216. Immediately afterwards, plutonium-216 will decay into lead-212, which has a half-life of 11 hours, and it is a beta emitter. The sniffer does not detect beta, therefore, the alpha activity of radon-220 will be nearly completely gone within the first 3 minutes. Essentially, within the time that I've been here speaking to you, if thoron was present, all recognizable activity would be gone. So to compare this to radon-222, which has a 4-day half-life, the activity does not change within 3 minutes. However, it does decay into plutonium-218, which is an alpha emitter, and it has a 3-minute half-life. That means if we start with 100 picocuries per liter of radon-222, after 3 minutes, you'll have 100 picocuries per liter due to the radon-222, plus an additional 50 picocuries per liter due to the plutonium-218. So looking at the activity over time, we can determine the relative amount of radon-220, or thoron, and radon-222 in an air sample. Radon-220 activity will decrease over a few minutes, whereas radon-222 activity will increase. So to measure thoron, or radon-220, we can follow this measurement sequence. Allow 5 seconds for the probe to get into a source, fill the cell for 90 seconds, and stop the pump and allow 300 seconds of filling. The simple explanation is that if the activity increases, we had mainly radon-222, and if it decreases, we had mainly radon-220. Using math, someone could figure out the ratio of radon-220 to radon-222 by analyzing how much of the count rate is increasing or decreasing. But this feature is already provided in the algorithm using the Radon Sniffer app, preventing the need to do the math ourselves. When running the sequence, it is important to make sure that there is no source escaping from the cell, because this will cause the count rate to decrease and the sniffer will think there is more thoron than there actually is. There are no valves on our sniffer. This means that you cannot leave the probe in a duct that is blowing or sucking compared to where the sniffer is, or you can pinch the hose to prevent the source from escaping. Another issue is that the calculation assumes a clean cell. If there is radon progeny in the cell, the radon algorithm may not be accurate. The team at EIC are currently working on improving our thoron module, but that's as far as we have it so far, so now we can move on to radon and water screening. So why measure radon in water with a sniffer? Well, there are specific guidelines in place for well water, and using a sniffer allows users to get a measurement within approximately 10 minutes. To measure radon in water, air needs to be continually bubbled through a water sample. This can be done using the exhaust of a sniffer. Newer sniffers come with an external brass exhaust port. However, we are aware that some of you may have already purchased sniffers that do not feature this external exhaust. We have small tubing here with us that can slide into the sniffer and attach to the internal exhaust port. So you can stop by our booth anytime today and we will provide you with these tubes. Once you have the air bubbling through the water sample, close the sniffer and the sample in an airtight container and use the sniffer to measure radon concentration in the air in the container. The volume of the air in the container is larger than the volume of the water sample, so we have to correct the air concentration reading by the ratio of the volumes to get the radon and water concentration. So these represent the setup. On the left, the water sample does not have any air bubbling through it. On the right, a hose from the exhaust of the sniffer is bubbling through the water sample. We also have a fan in the case to circulate the air, which we don't know if that's necessarily needed to be there. The airtight case will then be closed and we can read the sniffer readings on the app until they stabilize. So these graphs represent results from the two measurements. On the left, we did not bubble air through the water, but the jar was open and the radon concentration in the air in the case was steady around 275 picocuries per liter. When the water sample was being aerated, the radon level increased for 8 to 10 minutes and then leveled out around 1700 picocuries per liter. After we scale that with the air volume compared to water volume, it comes out to be about 60,000 picocuries in the water. Both of these concepts are still works in progress. Feel free to come visit us at our booth if you are more interested in these. You can also follow us on Instagram. We'll be announcing more updates there. It's just at Environmental Instruments Canada. Thank you for listening, and if you have any questions, you can email them to kai@eic.nu.